In this video, I'll be showing you how to build your own custom AI agent using LangChain and Retrieval Augmented Generation. Now we'll build this out using Python, and even if you're just an intermediate Python user, you can still follow along. You don't need to be a complete expert. What we'll do here is actually query information about one of our GitHub repositories and then make an AI agent that acts like a coding or GitHub assistant. That means that it can summarize different issues, it can actually respond to them if we want it to do that, and it can access different tools that we give it. So I'm on the computer now and I'll give you a quick demo of how this works. Now the first thing the agent is going to ask us is if we want to update the issues from GitHub. That's because we're going to go to GitHub and grab all of the different issues from whatever repository we select, but we don't always need to get fresh issues. Maybe only every day or every few days we actually want to do that update. So in this case, I've already updated the issues recently, so I'm just going to press no, and then what it's going to do is allow me to ask some questions about the GitHub repository or to utilize some different tools that we've given it access to. So it says ask a question about GitHub issues, so I'm going to say something like, hey, can you tell me what, and we'll do like this, what issues people are having related to flashing messages. Okay, so what it's going to do now is show us the thought process of the agent. You can see that it goes and queries in our tool, which is the GitHub vector search database. We'll talk about that in a second, for flashing messages. It then retrieves all of the messages that actually fit that criteria, and then it gives us a summary of them. So it says here are some of the issues related to flashing messages that people are facing, and then it spits out the different issues. Now what I can do is I can actually tell it to make a note of this, and it will utilize a different tool that it has access to actually save this information onto our local computer. You'll see what I mean, but the agent has various tools, and based on what we ask it to do, it can reach out and utilize those different tools. It's really, really cool, and you can expand this and make it really awesome. So I'm going to ask the same thing now, but I'm going to tell it to save a note. So I've just said, can you summarize the GitHub issues related to flashing messages and then save them as a note? So let's type this in now. You can see the first thing it's going to do is use this tool, GitHub search, with the query flashing messages, and then you can see it's invoking the note tool, and it saves all of the different kind of summary of, issues. So if we go here, this is the note that it just saved. It says flash messages not showing in the login page, an alert message in homepage, and then it gives us a description of the issues that people are facing. This is just a really small demo showing you what's possible in terms of building an AI agent. Obviously, you can build this out and make it that much cooler. And just as a final thing here, I'll show you that this is the GitHub repository it's working on. And if I go to issues, you can see that one of the first issues we have here is related to flashing messages. So you can see that's exactly what it found and then summarized for us and stored as a note. We could expand this and we could make it automatically reply to issues. We could even make it write a pull request to solve certain issues that people are having. With that said, let's get into the tutorial and let me show you how to build this out. So we're going to start building this project out now. So what I've done is opened up VS Code. I've opened a new folder, and this is where we'll write all of our code. Now the first step is to install a lot of different packages and dependencies, and then what we're going to do is retrieve the different issues we need from a GitHub repository. This can be your own repository or a public repository. I'll show you how we connect that and set that up. Then we're going to take those issues, we're going to store them in something known as a vector store database. We're then going to build out the AI agent, which will have access to the database, and it can query and look up specific issues really, really fast. That's basically the process. So we need to start with GitHub and getting everything set up. So let's do that right now. So what I've done is in VS Code here, I've opened up my terminal and I'm going to create a virtual environment to install the various packages that we need. Now, in order to do that, we're going to use the command python3-m venv, and then we can write the name of our virtual environment. In this case, I'm just going to call it GitHub. Now, if you're on Windows, you can change the command to simply say Python. So this is going to create a new virtual environment for us if we spell Python correctly. And then we can activate the virtual environment with the following command. Now, if you're on Mac, the command is going to be source and then github/bin/activate, like that. And then you'll see that we get this GitHub prefix in our terminal. If you're on Windows, the command will be slightly different, and I'm going to leave the command on screen. You may also just have to look it up because depending on the command prompt or PowerShell or whatever it is that you're using, the command could be slightly different. Anyways, I'll put something on screen, and then again, you might just have to look up exactly how to activate it because it differs based on the shell that you're using. Regardless, once the virtual environment is activated, we can install the different packages. Now, if you want a little bit of a cheat, you can go to the link in the description, and I have all of the finished code for this project already there. What you can do is copy the requirements.txt file. You can put that inside of this directory, and then you can install all of the requirements there. Or you can follow along with what I'm about to show you here, where we just install the different packages manually. So what we're going to do now is type pip install, and then we're going to write the different packages that we need. Now, the first package we need is Python, let's make sure we spell that correctly, -.env for loading in environment variables. We then need the request module. This is so that we can actually send requests to the GitHub API to get different issues. We then need the LangChain package. Okay, this is how we're going to actually write our agent. We then need the LangChain-Astra DB. This is because we're going to use Astra DB as our vector store provider. Again, we'll talk about how that works in a second. We then need LangChain, and this is going to be OpenAI, and then LangChain, and this is Hub. Okay, so let me just double check that those are correct. Looks like those are good to go. So again, python.env, requests, LangChain, LangChain Astra DB, LangChain OpenAI, and then LangChain Hub. We're going to install all of those in our virtual environment, and then we should be good to go. All right, so our virtual environment is set up, so now we can actually start writing some code. But what I'd like to do now is I'd like to get all of the different tokens and credentials that we're going to need for this project and just get them set up so we can do all of the coding at once, and we don't have to keep going back and forth between our browser and different websites. So what we'll do in VS Code is we'll create a .env file. Now this is an environment variable file where we're going to store all of the sensitive credentials that we're going to need because we're going to be connecting with various APIs, we're going to be connecting with a database, and we're going to be connecting with OpenAI. So bear with me here, and we're going to write out a few different keys that we're going to be filling in the next few minutes. So we're going to type GitHub token, and this is going to be equal to an empty string. We're then going to say Astra, and this is going to be underscore DB underscore API underscore endpoint is equal, again, to an empty string. We're then going to say Astra underscore DB underscore application underscore token is equal, again, to an empty string. We're going to say Astra underscore DB underscore key space is equal to an empty string, and then OpenAI underscore API underscore key is equal to an empty string. So we're going to fill all of these in with our own credentials. For Astra DB, this is the vector store database provider. This actually comes from DataStax, which is the sponsor of this video. Don't worry, they're free to use, and I'm going to show you how to set that up in just a second. So the first thing we're going to do is get our GitHub token. This is going to allow us to access the GitHub API. So what I'm going to do here is go to my browser. I'm going to go to GitHub, which conveniently I already have open. I'm actually just going to open this in a new tab so we can save that page. And what we're going to do here is click on our little icon, and we're going to go to settings. From settings, we're going to scroll down here to the developer settings on the bottom left-hand side. And what we'll do is we'll go to personal access tokens and then tokens classic. From here, we're going to create a new token. I've already created it, so I'm not going to make a new one here, but you can simply press this button, make sure you create a classic token, and then copy the token into the location that I showed you. All right, so you should have copied that token, and then you just want to paste it right here where it says GitHub token. Don't worry, I'm going to revoke this token after the video so you guys cannot use it. And the next step is to get all of our information for our Astra DB database. So what we're going to do now is go to this site right here, which is the DataStax website. Again, thank you to them for sponsoring this video and providing this database for free for all of us to use. You can simply click the link in the description and you'll be able to view it. Now let me quickly explain what this actually is and why we need it for this video. So we're going to be building a RAG application, Retrieval Augmented Generation. And what that means is that our AI agent is going to have access to, in this case, a database, something called a vector store database, where it can really quickly look up and query information. Now, DataStax is going to be providing that database through their product known as Astra DB. This is a very fast vector database that allows us to really quickly look up information based on similarity. So rather than dumping all of the different contents of our GitHub issues to to our agent, which it might not even be able to handle because it could be so much information, what's going to happen is the agent is going to utilize this vector database. It's going to query for a certain piece of information, and then it's going to be able to look up based on similarity. This is what the database is doing, all of the pieces of information that are relevant to the query, and then return just that data to our model so it can utilize it and give us some results based on it. So this is kind of the basic setup for RAG. Usually we are using a vector store database, and the way this works is we have vectorized information that allows us to search for information based on context, based on similarity, and that's much faster and more efficient than using a traditional SQL database. So I don't want to explain it too much. You can look up vector store databases if you want to learn more, but AstraDB has a free one that we can mess with for this video, and obviously they have paid plans as well if you want to scale this up to production. So what we're going to do is click on try for free here, and if you don't already have an account, make one. In my case, I'm just going to sign in. We're going to make a new database, and I'm going to show you how we can configure this. Alright, so once you've created your account or signed in, you'll be brought to a page that looks like this, where what we're going to do is click on databases, and we're then going to create a new one. Now you can see I already have one that I was messing with when preparing this video. What we can do is click on create a database. We're going to go with the serverless vector database, which is the one that I was talking about, and then we're going to give this a name. Now in this case, I'm just going to call this the GitHub agent, and then we need to choose a provider and a region. So I'm just going to leave it as Amazon Web Services, and I'll go with US East 2. Obviously, if you're upgrading to the premium version, you'll get some more options here, but for our case, this is completely fine, and we'll be able to do everything we need without paying for this service. Okay, so I've just done that here. You can see that it's initializing the database. This will take a few minutes. Once it's done, I'll be right back and I'll show you how we retrieve the information that we need to connect to this from our code. All right, so the database has been created now, and what we're going to be looking for is our API endpoint and our application token. So what I'm going to do is copy the API endpoint here. We're going to go back to our code and we're going to paste that in. And then we're going to do the same thing for our token. So we're first going to press generate token. It's going to give us one. Let's copy that. Obviously, you don't want to leak it like I am. And then paste it here. And for the key space, if we can go back here, this is something that you don't actually need to fill in. I'm just putting it here in case you do want to enter this information. You don't really have to concern yourself about what that is. Okay, next we need our OpenAI API key so that we can connect to OpenAI and use ChatGPT. So in order to do that, we're going to go to platform.openai.com/API keys. I can leave this link in the description. You also can probably find it pretty easily just by going to OpenAI, and we're going to make a new key. Now, I believe at this point you do need to actually add a credit card to OpenAI in order to utilize this. It should only cost you a few cents. If anything, it might even be free, but I just want to make you aware that you do need to have some kind of payment method here, I believe, as of the last time I did this, in order to use this API. There are other ways to run this project locally using something like Ollama, but we're not going to be walking through that in this video. So I'm going to click on create new key. I'm just going to call this my GitHub agent. Okay, it's going to give us a new secret key here, and we're going to copy this, and then same thing, go back to our code and paste this for our OpenAI API key. That is always a mouthful. Okay, so now we have all of our tokens and we can stay here in VS Code and actually write the completed project. So let's close our terminal and let's make a new file here called github.py, where we're going to write the first component of our project, which will go to GitHub and retrieve the different GitHub issues. So inside of here, we're going to start with our imports. We're going to say import OS. We are going to import requests. We are going to import, actually, we're going to say from.env, import, and then load.env. And then we're going to say from LangChain _ core dot documents, import the document. Okay, we're going to use that in a second. That's how we're actually going to wrap our GitHub issues and then pass it to our vector store database. Now, the first thing we're going to do is call this load.env function. And what that will do is search for the presence of a .env file and then load all of these environment variables for us. So you need this to actually load those different variables so that they're in the Python program and we're able to utilize them. The next thing we're going to do is grab our GitHub token. So we're going to say GitHub _ token is equal to os.getEnv. And then we're going to grab the name of that variable, which is GitHub _ token, which will now have been loaded from this function. Okay, next what we're going to do is write a function that will utilize the GitHub API. You don't need to set anything up here, you just need this token in order for it to work. So we're going to say define fetch _ GitHub. We're then going to have the owner, the repo, and the endpoint of the information that we want to fetch. Now what we're going to do is craft a URL here. So we're going to make an f string in Python, and this is going to be https://api.github.com/repos/ and then we're going to put inside of curly braces here the owner, the repo, and the endpoint. So you can see that we're making this dynamic. Let me just make this a bit smaller so we can see it, so that we can load any kind of repo that we want. We just need to pass in these different parameters. So that's how we're crafting the URL. And the endpoint would be something like the issues or a README file or pull request. We can grab different pieces of information. In this case, we're just doing the issues, but you could really easily adapt this code to grab all different kinds of info from your GitHub repository and then pass that to the agent. Okay, next thing is we're going to set up our headers. So we're going to say headers are equal to, and we're going to create the authorization header, which is what we'll need in order to actually send an authorized request to GitHub. So we're going to say authorization, and then this is going to be an f string, and this is going to be bearer, and then it's very important that you have a space, and then curly braces, and then the GitHub token. This is how we pass our authentication token so that we're able to actually send this request and get back a valid response. Next, what we're going to do is we're going to craft the request. So we're going to say response is equal to request.get. We're going to send this to the URL, and we're going to say that our headers is equal to the headers that we've just set up. Now what we're going to do is check the status of this response. So this will send a request to this get URL and give us some information back. So we're going to say if response.status_code is equal to 200, then we can say data is equal to response.json. So that's how we can actually load this. This will load it as a Python dictionary, the data we got back. Otherwise, we're going to say print, and we'll just say failed with status code. And then we can print out the status code, which will be response.status_code. Okay, then we can just return an empty array here. Otherwise, we'll come down here and we're going to return our data. Okay, perfect. So now that we have our fetch GitHub function, we're going to write a function that will call this and then get all of the results and wrap them as a LangChain document, which we're going to need for the next step, which you'll see in a minute. But for now, what we can actually do just to test this out is we can print, and we'll just print the data that we got before we return it so that we can see what that looks like. So let's call this function. So to call the function, we're going to say fetch GitHub. And then what we need to pass to this is an owner, a repo, and an endpoint. Now, what are the owner, repo, and endpoint going to be? Well, for the owner, this is going to be tech with Tim because that's my GitHub account. Obviously, you can change this to your own. For the repo, I actually need to find what the repository name is so that I don't mess it up. Okay, so the repo is going to be our Flask web app tutorial. I believe that you guys should be able to put this in as well because this is a public repository. And then the endpoint is going to be equal to issues. So now I'm going to pass this owner, repo, endpoint, and we can run our code and we can test to see if this is working. So let's clear and go python 3 github.py. and see if that gives us a result. All right, so you can see that we're actually getting a huge result here. I can't really scroll through all of it. It's pretty difficult to see, but the main important thing to understand is that this is inside of a list. And what this is doing is giving me all of the different issues with a bunch of different parameters and properties about them. Now you can look through this request and you can parse it however you want, but just trust me in the next step here because I've already looked through it and found the important keys that we want to extract. So what I'm going to do is close this. And now, let me just make this a bit smaller so we can see it. We're going to write a function that will take the results here and then wrap them as a LangChain document. So we're going to say define, and this is going to be the following. We're going to call this load issues. So we're going to say load underscore issues. This is simply going to take in the different issues. And then as I said, it's going to parse them and load them as a document that we can actually use in our Retrieval Augmented Generation program. So we're going to say docs is equal to an empty list. We can make this bigger again so we can see it. Okay, let's go up here. We're then going to say for entry in issues. Remember that issues is a list of all of the different issues that have a bunch of different keys. Now what we're going to do is create some metadata. So we're going to say metadata is equal to, and we're going to make a Python dictionary. The first piece of metadata we're going to want is the author. So in order to get the author from our issue, this is going to be entry, user, and then it's called login. Again, this might seem like gibberish, but I've gone through the issues, and these are all of the different keys that are in that JSON or that are in that Python dictionary that we need to access. Next, we're going to have the comments. We probably want that as metadata as part of the issue. So to have that, we're going to say entry and then comments. This is a list of all of the different comments that then contains some more information. We're then going to have the body of the issue, which is the main text description. So that's going to be entry and then body. We'll then have the labels. So maybe they've labeled this and that can help us get some context about the issue. So that'll be entry and then labels. And then lastly here, we're just going to get the created at date. So we're going to say created at, and then this is going to be entry and then created at. So this is metadata that we'll store with all of our different documents. There is a lot more information associated with the issues, but this is the important stuff that we're pulling out. Next, we're going to say data is equal to entry and then title. So we're going to get the title of this entry or of this issue because that's the main thing that we want when we're actually indexing or looking up these issues. And then what we're going to do is we're going to say if entry and then body. So if we actually have some body text or a description, because not all issues do, then we're going to say data plus equals the entry of the body. Now what this is doing is it's taking that description and it's concatenating that to the title so that when we add kind of the main content of our documents, which you're going to see in a second, we have both the title and the description, so we have more information so our model can perform better. So I'm going to say doc is equal to document, and then what we're going to do is say the page underscore content is equal to, and then this is going to be the data, so what we've just crafted right here. And then we're going to set our metadata. So we're going to say metadata is equal to metadata. So when we actually search in the database for this information, we're mostly going to be looking in the page content, and then metadata is additional information that's provided about the document. Okay, so that's why we've taken the title and the body and we've combined them together for the page content argument. Okay, now that we have this document crafted, we're going to say docs.append, and we're going to append this document, and then from this function here, we're going to return the different docs. Okay, we're almost done. We're just going to write one more function here. This function is going to say define, and this is going to be fetch underscore GitHub underscore issues. And what we're going to do is have an owner and a repo. And inside of here, we're going to say data is equal to fetch GitHub, and we're going to fetch the owner, the repo, and we're manually going to specify that we want the issues endpoint. And then we're going to return load issues, okay? And we're going to pass in here the data. Okay, so all I'm doing is writing one function that combines these two functions together. It first fetches the GitHub information that we need, it then loads the issues, and then returns all of that for us. Great. Now that we have that, what we're going to do is write another file. This file is going to be called main.py, where we're then going to import this code that we've written, and we're going to use it to actually load this in and store it in the vector store database. All right, so we're inside of main.py, and we're going to start with all of our imports. There are actually quite a few, and then we'll write the main kind of chunk of code here. Again, now at this point, I know we haven't really seen it or tested it, but we're fetching all of the different GitHub issues from our repository, and we're loading those as documents that we need to actually store in the vector store database. Now we need to connect to the vector store database and save that information, and then we can move on to writing the agent, which will have access to this database as a tool. So we're going to go to the top of our program, and we're going to say from .env import load.env. We're then going to import OS, and then we're going to import a bunch of stuff that we need from LangChain. So we're going to say from LangChain underscore OpenAI import, and this is going to be chat OpenAI and OpenAI embeddings. We're then going to say from LangChain underscore Astra DB, and we're going to import the Astra DB vector store. By the way, don't worry if I'm going too fast for you. You can always copy all of this code from the link in the description, or feel free to pause the video or slow down the playback speed. We then are going to say from langchain.agents, and we are going to import the create, and this is going to be underscore agent underscore, is this actually what it's called? No, sorry, create tool calling agent. That's the name of it. We're then going to say from langchain.agents import, and this is going to be the agent executor. We're then going to say from langchain.tools.retriever import, and this is going to be the create retriever tool. We're then going to say from LangChain hub import, and this is going to be hub, and then we're going to say from GitHub, which is the file that we wrote, import the fetch GitHub issues. Okay. Now we're going to call the load.env function, so we load in the environment variables inside of this file as well, and now we're going to connect to our vector store database. Okay, so what we'll do here is we'll write a function called connect _to _vstore, standing for our vector store. Inside of here, what we need to do is create something known as a set of embeddings. I'll talk about that in a second, and then connect to the Astra DB database provided by DataStax. Now, in order to do that, we'll load in the different keys that we have in our environment variable file. We'll create a new instance of the vector store, connect to it, and then I'll show you how we utilize it. Okay, so let's create some embeddings. We're going to say embeddings are equal to the OpenAI embeddings. And what an embedding is a way of actually kind of turning a piece of data, in this case textual data, into a vector. Now, a vector is something that exists in multi-dimensional space, and this is what we're actually storing inside of the vector store database. So these embeddings will be used by the vector store database to first take our textual data or our documents, convert them into vectors, and then we store them inside the database. So that's why we first need to use these embeddings. Now, these are provided by OpenAI, and the reason why this function here is going to work is because we've specified inside of the environment variable file our OpenAI API key. If we didn't specify that, this code wouldn't work because in the background, it's looking for that special environment variable. So we're using OpenAI here to provide us these embeddings, which is kind of like a mini machine learning model, which is going again and converting that data into vectors, which we can then store inside of the database. Okay. So the next thing we need to do is load in our Astra DB credentials. So we're going to say Astra DB API _endpoint is equal to os.getEnv, and then we can simply take this and we can paste it inside of here as a string. Okay. We then need our Astra _DB _application _token, which is equal to os.getEnv, and then same thing, we can take this and we can paste it inside of here as a string, and then we're going to have the desired _namespace equal to os.getEnv, and then same thing, this is going to be the Astra _DB _keyspace. Okay, this is going to be blank. We don't actually need to define this, but there's some more advanced configurations where you can. Again, we don't need to talk about that right now. So I'm going to say if the desired namespace actually exists, then we're going to say the Astra _DB _keyspace. Okay, let's write this out, is equal to the desired namespace. Otherwise, we're going to say the Astra DB keyspace is equal to none. The reason for that is when we load this in, it's going to give us an empty string. An empty string is not actually a valid option. So what we need to do is check, okay, is this an empty string? If it is, or if it isn't, sorry, then we'll just actually set it to this Astra DB keyspace. Otherwise, we'll set it equal to none so that Astra DB knows not to use this option. Okay, now we're going to say the vstore is equal to the Astra DB vector store. And inside of here, we're going to pass our different options. So we're going to pass embedding is equal to the embeddings. We're going to pass the collection name, which is kind of like the name of the database or the table. In this case, it's a non-SQL database, so it's not really a table, but it's called a collection where we're actually going to be storing our data. In this case, we're going to store it in something called GitHub, but you can change the name of this if you want. We're then going to set our API endpoint equal to the Astra DB API endpoint. And then we're going to have our token equal to our Astra DB application token. And then the namespace, oops, did not mean to do that. Let's close all that, equal to the Astra DB keyspace. Okay, then lastly, we're going to return our vstore, and that is our function to connect to the vector store. Now, what this will do is it will look to see if this collection exists. If it doesn't already exist, it's actually going to automatically create it for us. So just something to keep in mind there, the collection name GitHub, if it doesn't exist, well, it will just make it for us when it connects to it. Okay, so now what we're going to do is we're going to write a function, and we're going to say, we're going to write a line, and we're going to say vstore is equal to connect to vstore. The next thing we're going to do is we're going to ask the user if they want to update the issues. The reason why we're going to ask them that is we don't always need to update the issues in the vector store. It's only maybe every day or every few days that we're getting new issues on our GitHub repository, so it's inefficient to constantly do this. So we'll just manually tell the program when we want to update it, and only then will we actually hit the GitHub API and then do the operations with our database. So we're just going to have a line here. We're going to say add to vector store like that is equal to an input statement, and inside of here we're going to say, do you want to update the issues question mark, and then we're going to put our options y comma or y/N. The reason I'm doing a capital N is that's the default option. I'm then going to convert this to .lower, and I'm going to check if this is in the list of yes or y. So all I'm doing is I'm getting the input here, and I'm saying, okay, if what they typed in as lowercase is in yes or y, so if it's one of those two options, then that means yes, we do actually want to update the vector store or add our issues to the vector store, so then we'll go ahead and do that. Okay, so if this is the case, so if we are adding to the vector store, then what we're gonna do is we're gonna call the function that we had here, which is fetch GitHub issues. So I'm just gonna copy all of the code that we had here, because we no longer want that inside of this file. And we're going to paste that inside of here. So we have our owner and our repo and our endpoint. And we don't actually need the endpoint here because we're going to be using a different function. This function is fetch GitHub issues, where we don't need to pass the endpoint. We just pass the owner and the repo. Now what this returns is a bunch of different documents. Again, these are the documents generated by LangChain, which we can then use to add to our vector store. Okay, so now we need to add them to the vector store. So to do that, we're first just going to try the following. We're going to say vstore.delete collection. We're going to say accept and then pass. Now the reason I'm doing this is that if we are going to update the vector store, we first want to clear any issues that are currently in there in case, for example, an issue was deleted or resolved or removed since the last time that we updated it. So we're just going to clear the entire collection, so remove everything that we currently have, and then add all of the new issues that we've grabbed into there. Okay, so we're going to go here and we're going to say vstore is equal to connect to vstore. And then we're going to say vstore.add_documents, and we're just going to go here and add our different issues. And actually, sorry, issues is equal to fetch GitHub issues. Okay, let me quickly run through this because I want to make sure I'm not confusing any of you. We have our owner, we have our repo, we go and we fetch our different GitHub issues. We store those as issues. We then try to delete the collection in case it already existed. Now what I'm doing after this is I'm reconnecting to the vector store, and the reason why I'm doing this again, because you notice I have it up here as well, is because if we did actually delete the collection, then that means that we need to connect to it again so that it's automatically recreated. So you can see I have my collection named GitHub. If I delete it and then I just try to continue to use the vector store, well, we're not going to have that GitHub collection. So I try to connect to it again. So in case it was deleted, it will automatically be recreated from right here and then return to me so I can start using it. So it's slightly inefficient, but it's just kind of it's kind of the best way, to actually go about recreating the collection if in case we deleted it. Okay, so that's going to add all of the documents, but now we want to actually test and see if this database is working and if it can actually look up any of the GitHub issue information. So in order to do that, we can write the following line. We can say results are equal to, and this is just some test code we can delete after, and we're going to say vstore dot, and then we can use this similarity search, and we can pass inside of here something like flash messages, and we can say k equals 3, which is the number of documents that's going to be returned to us. So we could return more if we want. In this case, we'll just get the 3 most similar documents to flash messages. So we're doing a vector lookup here on all of the different issues. Okay, so now what we're going to do is say for res in results, because this will be a list of various documents. We're going to print the following, and this is going to be an f string. Okay, inside of here, we're going to put an asterisk, and then we're going to say that this is res.page_content, and then we're going to put here, this is res.metadata. Okay, so that should be good. And now if we run our code and we type yes or y, it should go to GitHub, fetch those different issues, and then print out to us the various results. So let's test this out before we go any further. Let me get out of this, however I ended up doing that. Let's clear this. I'm going to type python 3 main.py, and we'll see here it's going to give us some warning. We can ignore that for now. And let's give it a second here to connect and load everything up. And we got some issue. It says cannot import the name hub from LangChain hub. Okay, let me see what the problem is here, and then we can fix that. All right, so it's actually not the import of LangChain hub. It's just from LangChain import hub. My apologies, guys, on line 9 there. We'll fix that up. And we'll rerun our code now, and hopefully this time it will work. All right, so we have the prompt appearing here, so I'm just going to type in Y for yes so that we can update the issues and we can test this code. Okay, so you can see that that worked extremely fast. You can see that it printed out all of the different GitHub issues. Okay, so actually we're not yet at the similarity search. This was just me forgetting to remove that print statement from the GitHub code that we had. So no problem, but it did retrieve these different issues. And it's worth noting, by the way, this only retrieves 30 issues at a time. We could build in some pagination and we could get all of the different issues, but in this case, we'll just go with the 30 most recent ones, which is what it's giving us. And then the similarity search should work in a second, but it does just take a minute to actually connect to the, database, and then do that search operation. Okay, so we got an issue here that says document object has no attribute metadata. The reason why we got that issue is, well, because we spelt metadata incorrectly. Of course, another silly mistake. We can quickly fix that, and we can rerun our code one more time. I'll fast forward through it, and we'll just make sure that this works. All right, so the code did indeed work, and you can see here that when I scroll through kind of the results, that we get a bunch of different kind of similarity searches, or similarity search results, sorry. So it says alert message and homepage, and then it spits out the whole body here. Hi there, so as I'm following the video, blah, 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 this was the issue. And then it gives us information like the author, the comments, and everything else that we specified here in the metadata. So that's pretty much it in terms of doing the similarity search. I just wanted to show you that that does work and how you can test it out manually by using this line of code right here. We don't actually need this, so I'm just going to comment it out. And now what we're going to do is move on to actually writing the agent, and we're going to provide this vector store, so the one that we wrote right here, as a tool to the agent, and it can decide when it needs to use it. So that's the really cool part about agents. We just give them these different tools. In this case, one of the tools is the Retrieval Augmented Generation part, so our vector store database. And if it needs to use it, it will. If it doesn't need to use it, it won't. We're also going to build another tool, which is just a Python function that will allow us to save a note. Okay, so let's go and do that. So since this is going to be a tool, we need to wrap this as a tool. In order to do that, we're going to say retriever. And did I spell that correctly? I'm not really sure, but I think that's fine. Will be the vstore.as_retriever. We're going to go here and say the search underscore quargs are equal to, and this is going to be K3. So it just returns 3 documents. If we wanted to return more documents, we can set this to 5, 10, whatever we want. Okay. Then we're going to say the retriever underscore tool is equal to the create retriever tool, which we imported earlier. We're going to pass in here the retriever, and then we need to give some description to what this tool is. So we're going to say GitHub underscore search. So what we're doing first is we're providing the name for the tool, and then we're going to write a description of what the tool does and when the agent should use it. So this is kind of how the tools work. We provide what the tool actually is. In this case, it's a vector store database. LangChain will automatically kind of allow the agent to invoke this and start querying for different documents, but the agent needs to know when to use it. And in order to do that, we have to provide it that data. So we say, okay, the name is GitHub search, and then the description is going to be whatever it is that we want to tell the agent that this tool is about. So I'm just going to copy in the description to save us a little bit of time. You can modify this and see if it works better for you, but this was working well for me. This says, search for information about GitHub issues. For any questions about GitHub issues, you must use this tool. Okay, so really straightforward. I'm just telling it what the tool is and when it should use it. And now that we have that tool, what we'll do is start setting up our chain of kind of different prompts and return types and all the things we actually need in order to run this agent. So now that we have this tool set up, and by the way, we're going to write another one in a second, we need to have a special prompt that kind of tells our AI, in this case, it'll be ChatGPT, how to utilize these tools and how it should behave. Now, rather than writing our own prompt and trying to come up with one, we can actually just download one from LangChain Hub that's automatically configured to do everything that we want. So we're going to say prompt is equal to hub.pull, and bear with me while I write this out. This is hwchase17. This is going to be /OpenAI, and then functions_agent. Okay, so this is a special prompt for OpenAI or for ChatGPT that tells it how it should behave and how it should utilize the various tools that we give it. That's it. This is just going to download it for us and automatically inject it into our code. If you want to view how it works, you can just go to this URL, or you can just look this up on LangChain Hub, and you can see kind of what the prompt looks like. Now that we've done that, we're going to create the LLM that will use our various tools. So we're going to say LLM is equal to chat OpenAI. We don't need to do any other configuration because in our environment variable, we've provided the OpenAI API key. Okay. Now what we're going to do is we're going to say tools are equal to, this is going to be a list because we can provide as many tools as we want. In this case, we'll have the retriever tool, and in a second, we'll add another tool. And we're then going to make our agent. So we're going to say the agent is equal to the create tool calling agent, a function from LangChain. We're going to pass the LLM, we're going to pass the tools, and we're going to pass the prompt that we want to provide to this agent. And by the way, you can customize this prompt if you want. I'm just not going to show that in this video. Okay, so now that we have the agent, we actually need something that allows us to execute the agent. Now that's called the agent executor. So we're going to say agent executor is equal to agent executor, which we imported above. We're going to provide to that our agent, which we just created, and our tools, which will be equal to the tools. And then we're going to say verbose equals true. Now what this means is we're going to get all of the details on the thought process of the agent so we can see what it's thinking and how it's selecting the tools. If you don't want to see that and you just want the output, then you can set this variable to false. Okay, so we're almost done at this point. Now what we need to do is just write a loop where we utilize this agent executor so that we can continue to ask it various questions, and then you'll really see this project come full circle. So we're going to say while, like this, and I'm going to write some fancy Python code. I'm going to say question equal to, and then this is going to be input, and we're going to say ask a question about GitHub issues. Okay. And we're just going to specify Q to quit, because if you type in Q, then we're going to quit. And I'm going to say while all of this does not equal to Q, because if you type in Q, then we're going to quit. Then what I'm going to do is say my result is equal to the agent executor dot invoke. And I'm going to invoke this by passing in a Python dictionary that has a key input and the value of question. I'm then going to print the result and the output. There's a few other keys you can look at here, but all we really care about is the output. Let me make this a little bit smaller just so we can quickly summarize what we've done before we run this code and then write our additional tool. So you can see that we have tools equal to retriever tool. We create the tool calling agent. You don't really have to worry about exactly what's happening here. This is just a function from LangChain that, again, takes the LLM, takes the tools, and takes the prompt and creates that agent for us. We then need an executor so that we can actually utilize the agent. So again, pass the agent, pass the tools, specify if we want the detail about the thought process or not. Then we write some code here. We're saying while question equal to. Now this is what's known as the walrus operator in Python, and it allows us to actually define or declare a variable while we have it as part of a condition, which is what we've done here. So all we're doing is setting the variable question equal to the result of this input, and then making sure it's not equal to Q, because if it is Q, we're going to quit. Then we take this question, we pass it to the agent, and we print out the result. Okay, so before we test this, let's write that last additional tool. It's really simple. It's going to be just a few lines of code. So let's make a new file here, and we're going to call this note.py. And all I'm going to show you how to do here is how you wrap a Python function that can be literally anything you want as a tool that you can provide to your agent. So we're going to say from LangChain underscore core dot tools. We're going to import tool, which is a decorator. We're then going to say define note underscore tool. We're going to pass in a parameter called note. Okay, and then we're going to write a doc string. Now the doc string here acts as the metadata or the description of the tool, so make sure you write a good doc string that describes what this function actually does and how it acts as a tool. So I'm going to say saves a note to a local file, and then you need to make sure you specify the arguments that this function takes in. In this case, it takes in one argument, which is a note, and we're going to say the text note to save. Okay, so this is equivalent to what we wrote manually for the other tool, and also the name of the tool will be the function name. So make sure you give it a good name. Then we're going to decorate this. We're going to say @tool. What this does is convert this into something that can be passed as a LangChain tool to our agent. So take in how easy that is. You write the function name, you write a little bit description of how the function works as well as its different arguments so that the agent knows how to call it and what it is, and then you just write the function body on what you want it to do. So in our case, we're going to say with open, we're going to open a file called notes.txt. We're going to open it in A mode, which stands for append. We're going to open it as f, and we're just going to say f.write, and we're going to write the note plus the \n, which just means we're going to move to the next line. That's it. That's our note tool, and we could write as many tools we want like this that are Python functions that the agent has access to, which I just think is really, really cool. Okay, last thing, let's make a new file called notes.txt, just so that that file exists, so that when we try to open it in append mode, we don't get an error. And then we're going to go to main.py, we're going to import this tool, we're going to add it to the list, and we're done. So let's go to main, let's go up to the top here. We're going to say from note, import the note underscore tool, okay? And we're going to go to our tool list. It's as easy as this. We're just going to add it into the list. So we're going to say note underscore tool. And now we can test out our agent. So in under an hour, we've been able to build this, which I think is pretty impressive. Let's clear and let's run our code. So Python 3 main.py, and let's see what we get. So we don't need to actually update the issues here because we updated them recently, so I'm just going to go with no. And then we should get a prompt popping up here saying, hey, ask us some questions. Okay, so it does. So I'm going to say, hey, can you answer or can you tell me about issues related to flashing messages? Okay, so it's entering this. You can see it's using the GitHub search with the query flashing messages, and it finds a bunch of different results here. Okay, and then it gives me a summary of them. I found some issues related to flashing messages. You can see that it found 2 different documents here. And it says, let me know if you need more information on these issues. So you can say, hey, that's great. Thanks. And you'll notice in this case, it's not actually going to use any of our tools because it didn't need to. So it just said, you're welcome. If you need any more help, let us know. That's the beauty of an agent. It knows when to use the tools. So now I can say something like, hey, can you save a note saying hello world? So now what it should do is use the note tool, which it is. And you can see if we go now to our notes, so let's go to notes.txt, we have the note hello world. Now what we can also do is we can combine multiple tools together. So I can say, hey, can you summarize a few issues from GitHub related to Flask, and then save them, or save the summary as a new note. Okay, so now it should use both of these tools. So the first thing it's doing is querying for Flask. Okay, it found some issue here related to Flask. That's great. That's what we're looking for. Okay, now it's invoking the note tool. And you can see that when we look here, it says these are the issues, or this is the issue that it found, and it just saved a note related to it. Now, this wasn't the best result in the world. Obviously, we could fine tune this and maybe make the prompt better, but you get the idea. The agent is working, and we have now completed it. So that's it, guys. That's how you build a complete AI agent that implements RAG in under an hour, that goes first and queries GitHub, finds different issues, and can really act as a coding or AI assistant. This is super cool. Obviously, we just built something really simple in this video, but you can extend this, you can make it much more complicated, and you can make it a lot more effective. Imagine if you were pulling GitHub issues, pull requests, maybe you had a code generation agent too, and you combine those together, you can make something amazing. I hope you guys were excited about this video and enjoyed. If you did, make sure to leave a like, subscribe to the channel. Big thank you to DataStax for sponsoring this, and I will see you in the next one.